The cranial and the spinal nerves are part of the peripheral nervous system. Now, I've already gone through the central nervous system quite a bit. It's time to look into the peripheral. Your peripheral nervous system is everything outside of or beyond the brain and spinal cord. That means it's every nerve in your arms and legs and torso, every nerve ending. All these pieces and parts that make up all your nervous system outside of your brain and spinal cord are the peripheral nervous system. They have tons of sensory receptors. It's how you bring all your information into the central nervous system. So for example, we have free nerve endings. Now we saw these back in the integumentary system in the skin, but it's literally just a nerve that goes up into the skin, doesn't have any special features or attachments. It's just the end of the axon. We have tactile discs, known as Merkel discs. These are some pressure receptors, more of a light pressure receptor. Hair follicle receptors. Maybe you've ever had an insect land on your arm and you can feel just the hair move, or that light breeze just blows against your skin and you feel the hairs just move a little bit. Those would be the hair follicle receptors. We have the lamellar corpuscles, or they're known as the Pastein corpuscles. A little more of a deep pressure receptor in the skin. And then the last one listed here is muscle spindles. Now these are inside your muscles, where if the muscles stretches too much without you consciously moving it, it sends signals into your brain saying, hey, protect this, this is not moving the correct way. Or even if you are moving the muscle, but you go beyond the normal range, you extend the muscle too far, or you put too much tension on the muscle, it can give feedback into your brain and spinal cord to try and protect that muscle. Make sure you're not damaging that muscle. All right, so we know this is the peripheral nervous system. You have nerves, nothing new there. But then you can see the term ganglia. Remember, ganglia is the grouping of cell bodies of the neuron in the peripheral nervous system. So that nuclei was the term we talked about in the central nervous system. They're now ganglia in the peripheral, groupings of the cell bodies of the neurons. And then I had the term motor endings. Well, sure, all that motor output coming from your brain and spinal cord, going into the muscles, into the glands, basically creating some movement, creating some end result. So we have all of these nerves carrying this information and working a whole network throughout your body. The biggest thing here is it's linking the internal and external environment. Basically, think of it this way. Temperature, is it warm or cold? Can you feel a breeze? Is there anything moving around? What are you seeing as you bring that in there? What are you hearing? What are you smelling? What are you tasting? All these external features, including pain for that matter too. There's tons of these external stimuli coming in that the peripheral nervous system brings into your central nervous. Your central nervous decides what to do and then sends that motor output back out. So it's kind of important to have this whole entire peripheral nervous system linking the external environment to the central nervous system, the brain and spinal cord. Now, we've seen this classification of nerves before. We have the sensory or the afferent. Sensory is input coming in. Same thing for afferent, input. That's bringing it into the central nervous system. Motor or efferent, that's the output. Things leaving the central nervous system. So think again, E, exit, efferent, leaving. That's your motor output. And then the mixed. Now, the mixed will be the most common type of nerve in your body. Mixed means it has both the sensory and the motor side to it. So this mixed actual nerve, now it's careful, it's a mixed nerve, not a mixed neuron. But a mixed nerve can have some sensory neurons and some motor neurons grouped together. Because the individual neuron, again, it can only go one direction, sensory or motor. But in a nerve, which is a clustering of neurons, you can have sensory and motor neurons grouped together. So mixed is by far the most common type of nerve in our body. So we're looking at the structure of a nerve. We have these 3 different layers of connective tissue. Now, if that sounds kind of familiar, it is, because go back to the muscles. The skeletal muscles we talked about had 3 layers of connective tissue. But since we're in nerves now, we have different terminology. The outside covering is the epineurium. So the outside covering is epineurium. That's what's going around the outside of your nerve, the epineurium. Then inside, just like in muscles, we have fascicles. Each fascicle, this whole thing's a fascicle, is going to be covered by the perineurium. So perineurium wraps around the fascicle. Then inside the fascicle are going to be the individual axons. Each one of these is going to be your axon. So these little tiny circles inside the fascicle, those are these axons blown up. Now each axon is going to be covered or wrapped by the endoneurium. So the wrapping around the individual axon is going to be the endoneurium. So 3 distinct layers of connective tissue, just like in the muscles. These 3 layers, though, have a unique term for the nerve. We're going to have our epineurium, we're going to have our perineurium, and we're going to have our endoneurium. Endo inside wraps the axon. Perineurium wraps the fascicle. And the epineurium, epi above, wraps the whole entire nerve. And just to reiterate back to the whole sensory motor, individual axons, that one could be a sensory. This could be a sensory. This might be a motor. So you have the different possibility of different neurons being sensory or motor grouped together inside of an actual nerve. Now, a lot of times the ones that are grouped in a fascicle could just be all sensory. The next fascicle might be motor, or each fascicle could be mixed sensory and motor. So a little bit about the structure of the nerve, from the coverings to what's inside and how they work.